Solve a formula for a specific variable. So we have an example here. They give us an equation, A equals 1/2 BH. And maybe we know what that's an equation for, maybe we don't, but it doesn't matter to us. What we're supposed to do is we're supposed to solve for whatever they tell us to. And so we're going to be solving for B in this case. So it means we want to get B by itself. So we use the same principles we use to solve equations. I'm going to rewrite it. Now in this case, I want to get rid of that 1/2. So what I'm going to do is I'm going to multiply by 2 on both sides of the equation. So whatever I do to one side, I've got to do the other side. I'm multiplying by 2 to get rid of that 1/2 there. Now I have 2a, and I think we talked earlier about if it's a capital A, keep it a capital A. The B and H are both lowercase, keep them lowercase. So that's standard. That's important, especially in our science classes, but in our math classes as well, just get in the habit. Okay, so now I've got 2a equals BH. I'm trying to solve for B, meaning I'm trying to get B by itself. So I'm going to go ahead and divide both sides by H. And then I have 2a over H equals B, because those H's cancel out. Usually we write it, though, as B equals 2a over H. And so you might have a question, well, why would you want to do something like that? Say you had a lot of information data, you had a lot of data for A and a lot of data for H, but you were trying to find, what B was, and you were going to do this a bunch of times. Well, by solving for B, we can put this equation in a computer, put in the data, and then it can calculate those things for us. So it's one way you might use it. Okay, so here's another formula. It's a little bit different formatting than the last one, and this time we're going to solve for C. They always have to tell us what letter we're going to solve for. So in the first example, we had 3 variables, A, B, and H. In this example, we just have 2 variables, F and C. Okay, so here we go. I'm going to recopy it. F equals 9/5 C plus 32. So I'm trying to solve for C, trying to get C by itself. First thing I'm going to do is subtract 32. Now, what happens then on the right-hand side, or on the left-hand side, I get F minus 32 equals 9 over 5C. Okay, so that's where we're at. We're trying to get C by itself. We need to get rid of that 9/5. So we're going to multiply by the reciprocal on both sides. So I'm going to put 5 over 9 right here. I'm going to squeeze that in. And then on the other side, on the left-hand side, I also have to multiply by 5 over 9. Notice that I put those parentheses in. Okay, so the 5's cancel on the right, the 9's cancel, and we just have C. So the final answer is going to look like this. C equals 5 over 9 times F minus 32. And I would just leave it that way. This is actually the formula to convert from Fahrenheit to Celsius. The original formula, what we started with, would convert Celsius to Fahrenheit. And then it's usually left like that. So, okay. I think we've got one more. Nope, 2 more. Okay. So here's another one. And we're going to solve for R this time. So it's a little similar to the last one. We start out with A equals P plus PRT. And so I want to get R by itself. I'm going to go ahead and subtract P from both sides. And that's going to give me A minus P equals PRT. And now I want to get the R by itself, because it tells me to do R. So on the right-hand side, that's where the R is. I need to get rid of both P and T. So I'm going to divide by P and T. And I'll do that on both sides. And then those P's cancel, those T's cancel. And so I just have R equals A minus P all over P, T. And there might be other ways to write it, but that's how I would write it. Okay. And then we have one more. This one's in terms of x and y. Previously, a lot of those formulas were actual formulas that we use for different things. This one is just an equation in terms of x and y, but we want to get y by itself. So, and sometimes we have to do this when we get to the graphing chapter. So I see the y there. Let me recopy the problem. I always feel obligated to do that for some reason. And I'm going to go ahead and subtract the 4x from both sides. Now, this came up on another problem. We did something similar a minute ago. Why am I leaving that 9 minus 4x? Well, I can't combine them. They're not like terms. I could rewrite it if I wanted to. I could put that over 7. Or, I'm sorry. I could put this, 7y equals negative 4x plus 9. And then I'm going to want to divide everything by 7. So divide by 7, divide by 7. Now, I get this answer, y equals negative 4x plus 9 over 7. That's fine. That's an answer. But sometimes we want to see it in a particular form where the two terms are separate. And we can do this. I'll just point it out now because it's going to come up later on. We can write it like that. And if you've done some graphing in the past, that's the y equals mx plus b form. So either one of those answers is fine. Just kind of depends on what form you want and what you're doing, but let's put an or there. But I wanted to point out that you can do that for the bottom just to get the x term separate from the constant so you can see it a little better. Okay, and that's it.